Given the initial value problem right here, so we have, I'll use the pointer. So we have this function, slow function right here, and then we have our initial value and our initial time, and then we have our step. We have the butcher tableau that describes a numerical method, and they ask us to do what? Find K1 and K3, and the next time step, computing 1/4 time step. Okay. And then the global error, the local error, and what H reduces the global error by 50%. So here's what we need to understand. So this is my K1, this is my K2, and this is my K3. And this is my stage one, this is my stage 2, and this is my stage 3. And this is finally my next step. So the idea is, if we have 3 stages, we have a third order method. And so we can start answering, what is the global error? It is on the order of h to the third. The local error is going to be 1 less than that. We assume that h is less than 1. So, sorry, not 1 less than that. It's going to be an exponent higher than that. Now, what reduces h? What h reduces global error by 50%? Well, they give us h, right? Yes, h is right here. So here's what we're going to do for this question right here. We're going to write an expression. We're going to say h, the global error is h to the third, and we want to divide that global error by 2, which is 50% of the original global error. And we want that to be a new value, k to the third also, because that would be the new global error. So now we can solve for k. So k is going to be equal to the cube root of h to the third over 2, which is equal to h over the cube root of 2. Now, h is 0.05. We divide by the cube root of 2, and what do we get as an answer? So, right here, we're going to have, I'm pulling out my calculator, 0.05 divided by the cube root of 2, I get 0.039, we got to round down. So it's 6/8, but I'll round down to 6. Otherwise, we might get more than 50%. So this would be my answer to that question. This would be my H, my new H. This is my new H. Now, let's try to understand K1, find K1 and K3, and then compute the 1/4 time step. And we'll do it by hand, and then I'll also show you how to do it on the computer, just in case there's more than one step that you have to take. You don't want to do that by hand. So, all right. So, basically, the first stage is going to be my slope function at tk, which is the t at which we're at, plus 0 times h, because this indicates whether we're adding h or not. And then on the other side, so this kind of symbolizes the comma, we're going to have what? We're going to have our x sub k plus 0 h k1, k2, k3. So just this. And this is our stage 1. How about our stage 2? Well, now we have t sub k plus h over 2. Here we have the 1/2, right? And then for K1, we have 1/2 as well. So h over 2 k sub 1. But then we have 0 for k sub 2 and k sub 3. Then we have our third, which is what? And so this is my K1. this is my K2, and this is my K3. And so now here we're going to have T sub K plus 3H over 4, comma, X sub K plus 3H over 4, K, which one's that one? This one's K2, K sub 2. And now finally, we have the X sub K plus 1, which is going to be equal to X sub K plus H. We can do, so notice how if I multiply the top and bottom of this by 3, I get common denominator of 9, so I can basically pull the H over 9 out, and then I'll have 2K1 plus 3K2 plus 4K3. And so now we know what our H is, so we just kind of have to evaluate it. Actually, I said I was going to do it by hand. I feel like that's too much work. So let's go over to MATLAB and see how we can program this. So we want to program this stuff, program into MATLAB. And so we'll do a part B for this.